The next thing I want to do is explain how to rotate the block sphere. So let's write down these matrices. Minus I, 0, I, 0, and sigma z equals one minus 1, 0, 0. So these are all two-dimensional matrices, which means they perform transformations on a two-dimensional state space. So, and these are the three Pauli matrices, sigma x, sigma y, sigma z, and let's try to figure out what transformations they perform. So 1 over root 2, no wait. 1, 0, what happens when we apply sigma x to 1, 0? We get 0, 1. What happens when we apply sigma 1, 1, sigma x to 1, 1? We get 1 over root 2, 1, 1. And if we have 1 over root 2, 1 minus 1, it goes to 1 over root 2 minus 1, 1. So what does that do to the block sphere? Well, 1, 1, which happens to be the x-axis, is left unchanged. And if it takes minus the z-axis to plus the z-axis, and it took minus the y-axis. Okay. Yeah, 1 over root 2, 1, 1, 1 minus 1 goes to 1 over root 2 minus 1, 1. 1 over root 2, 1i goes to 1 over root 2 I1, which happens to be equal to 1 over root 2, 1 minus I. But this is just the negative of this. So as I said before, this is essentially the same vector as this. So so it leaves this vector unchanged. It leaves this vector unchanged. It takes this guy to the top, and it takes this minus y, or this minus y unit to the y unit, and vice versa. So it's a 180-degree rotation around the x-axis. And I'm not going to go into the calculations, but this and this are 180-degree rotations around the y-axis and the z-axis. So this is, and you see that this transformation just rotates the block sphere. And in fact, all the quantum transformations you can do essentially rotate the block sphere. So let's figure out another one. H is equal to 1 over root 2 minus 1 over root 2, no, 1 over root 2, 1 over root 2, 1 over root 2 minus 1 over root 2. Okay, what does that do? Well, it takes a vertical, which is 0, to 1 over root 2, 1 over root 2, which is 0 plus 1 over root 2, to the right. And in fact, if you square this, you get the identity. because you square this, you multiply this by that. I mean, 1 over root 2 times 1 over root 2 plus 1 over root 2 times 1 over root 2 is 1. And this times this plus this times this is also 1. And the other two terms are 0 because they have a plus and a minus in them. So h squared equals I. And so it interchanges that and that. Well, the down, if you have 0, 1, you get 1, you get a 1 minus 1 vector. So it interchanges that and that. And what does it do to 0 plus I1? Okay, that maybe I need to, so that's 1I is equal to, well, okay, this gets complicated. 1 plus I, or 1 over 2, 1 plus I, gives you 1 plus 1/2. So the top thing is 1 plus I, and the bottom thing is 1 minus I. Well, you can multiply the top and bottom of this by 1 plus I over root, or 1 minus I over root 2. 1 minus I, 1 minus I. 1 over root 2. So this is a, so we're essentially multiplying the whole thing. I mean, this is supposed to be a scalar, I'm sorry. 1 minus I. So this is a scalar, and it's a unit scalar. So it does not change what this vector really is. And the top thing becomes 2, and canceling all the powers of 2 out, you get a 1 over root 2, 1. And the bottom thing, 1 minus I times 1 minus I is 2I. You get minus I. So what you've done is you've swapped the top, the front and the back of the sphere. So it's not a reflection because you've taken this guy to this guy, this guy to this guy, and the front, back to the front of the sphere. It's a rotation around, I should have brought colored chalk clearly. It's a rotation around this axis. Okay, so there are a lot of, so, yeah?
In terms of x, y, and z, what is the vector that points in the direction of that axis?
Okay, so this rotation around, well, this is cosine pi over 4, or rather, 1 over root 2, 1 over root 2 is cosine. Okay. Cosine pi over 8, sine pi over 8, really. And I forgot to put cosine pi over 8. The y-axis is 0, and the z-axis is cosine pi over 8, and the y-axis is 0, and yeah, so sine pi over 8, cosine pi over 8. So what, this 1 over root 2, 0, 1 over root 2 is cosine pi over 4, sine pi over 4, 0, cosine pi over 4, and 1, 0, or 0, 0, 1. which is this point in, I guess, Euclidean coordinates, is sine 0, 0, cosine 0. And this point is supposed to be halfway in between them, so it's really sine pi over 8, 0, cos pi over 8. And that's good. So so we're going to be doing a lot of quantum gates. Yeah, another question?
Yeah, so H is basically like normalized sigma x plus sigma z, and the like axis of rotation is basically like the x plus the z. Actually, is that in general true that like if you decompose it, then you can figure out the axis based on that?
Yes, and well, there's a very nice formula for exactly how rotations correspond to axes, which we won't get to yet, but we should be doing it at some time in the next few lectures. But what do I want to say? I want to say that you need to know that we need a little more background before we can go into it.